One of the handouts that I made available this morning on e-learning was this one here. This is the review assignment. And you can see this is a massive table here, but this table is such that any graph that you construct in chapter 2 will use a combination of a couple of these columns, not all of them. So for example, the class, this is going to be related to the x-axis variable, so it's going to be at the horizontal scale. The upper class limit is the x for an ogive. Because many of these graphs that we saw back in section 2.3 are xy graphs, so we need an x and a y. The midpoint is also the x coordinate, but it's the x coordinate of a frequency polygon. The frequency and all the rest of these that deal with frequencies are what we put on the vertical axis, so it's going to be on the y-axis. We use frequency or relative frequency if we're going to be doing a frequency polygon, and if we do a histogram. And we use those y's there if we're going to be doing working with an ogive. And there are two possibilities, but the vertical axis will either be the frequency or it will be the relative frequency. And a lot of times relative frequency is better because those are the ones closely related to percentages. And we have a lot of intuition about percentages and what they mean. All right. We're going to take this data. This data here represents the serving size of several sandwiches at McDonald's and Burger King's. So you can see as you look through the data here that they're all 3-digit numbers. So one of the things you want to do for a data set is to identify the smallest data value and the largest data value, because those two numbers are going to help you establish all of these classes down here. And so go ahead by inspection, take a look. What's the smallest data value that you see in that list? Go ahead and write it in the chat. Then go in and write the max as well. What's the largest data value? And write that in the chat. The minimum is the smallest data value and the maximum is the largest data value. In this context, the minimum is the smallest serving at McDonald's and Burger King. All right, so yeah, it's hard for humans to look through the list and identify those. There's so many of them, they're all 3-digit numbers, but most of you got it right. You're correct, it's 100 and 459. Those two numbers are going to help us in the following way. We're going to calculate a statistic, it's called the range. And this is one that's actually introduced in section 3.2. It's one of the statistics that we use to describe the spread in the data. Another word for spread is dispersion. So we take the max minus the min, and it's just a subtraction. And in this case, it's a pretty easy one. We can do it in our heads, 359. So what we would say then is we would say that all of the sandwich serving sizes fall in a range of 359 grams. So it kind of gives us a sense of how spread out the data are. And if you think about a histogram, we actually start our first bar at the first data value, and we'd like to end our last bar at the last data value. So we start at the min and we end at the max. And that range right there is 359. So in a histogram, we want to chop that 359 into equal bars so that all the bars are the same width. And in this case, they tell us to use 8 classes. So we're going to take that entire range and we're going to chop it up into 8 equal classes. So if you're wondering what the class width is, you get it by looking at the range and then chopping that range into the number of classes. So here's the how you would start identifying the numbers that go in this column here for the class size. So it's the range divided by the number of classes. Now, I'm going to write approximately equal to here because it's not always going to work out to a nice whole number. So, and all of our data values are whole numbers, so we want our class values to be whole numbers as well. But in this case, we're going to take the 359 and divide by 8. And each one of those bars would be 44.875. Now, we always want the class width to be have the same unit as our data values. And all of our data values are rounded to the nearest whole number, so we want the width to be rounded to the nearest whole number. So we're going to say that the class width is equal to, and we're always going to round this number, even if mathematically it does not round up to the nearest whole number, we always want to round up. And so for this one, turns out that if we round it or we round it mathematically, you get the same thing. But the class width is 45. So if it's 45 and we start at the minimum data value, then we will capture all of the data values. Okay, so now let's work on this column. This is important first step, because if you get the class wrong, then you're going to get everything else wrong. All right, we're going to start always at our minimum data value. There's no need to start at 0 here, because from 0 to 99, there are no data values. And we certainly, don't want to start our graph with 9 different or 2 or 3 different empty bars. So we're always going to start at the minimum. And then we want to go up to, we want to add the class width. So the bar is going to start at 100, and we're going to add 45. When we add 45 to 100, we get 145. Now, 145 is not going to go here, because if we put 145 there, then we're going to actually have 46 data values in that first. Because if you started at 101 and counted from 1 to 45, you'd have 45. Plus the 100 would give you 46 data values. We don't want 46 data values. So the way that you're going to use the class width is you're going to add 45, but you're going to add 45 to the 100, and that becomes the beginning of the next class. So that means the end of the first class, we call that the lower class limit is 144. Now when we construct a histogram, we're going to start at 100, and we want 8 equal bars, and we want them to be 45 long. So if we go from 100 to 45, that would be this. If we add another 45, if we were to stop at 144 and just draw a bar for the first class that ended, then we would have a couple of bars that would have a gap between them like this. And for a histogram, we do not want a gap between our bars. So what we're going to say instead is we're going to start at 100, and our next class would be 145, but we're going to understand that we're going to include all data that is greater than or equal to 100, but less than 145. So if we encounter the data value 145, then data value 145 is actually going to be counted in this next class. And the data value in this class would be greater than or equal to 145, but less than 190. So if you hit the 190 data value, then you're going to the next one. And this would just continue with all of these other. All right, so I'm just going to go ahead and add the 45. If you want to do this quickly on your calculator, you can type in 100 and hit enter, and then say plus 45, and then just hit enter over and over again, and it does that last calculation. And you can get all of those numbers fairly quickly just by hitting enter over and over and over. So I'm going to enter these numbers as our lower limits over here. 190, 235, 280, 325, 370, and then 415. If I continue that pattern, 460 would be the beginning of the next class. But remember, our maximum was 459. So we're not going to have anything in a 460 or above class. So we'll have captured. And then, in order to get the lower limit of each one of these classes, just peek ahead. If the beginning of the next class is 145, then the ending of the previous class has to be 144. You want to make sure that all those whole number data values have a home. So you don't want to skip any of them. If this is 190, if this is 190 here, then this one must end at 189. If this one is 234, then this one, or 235, then this one must be 234, and so on. Another way to think about it is if you just added 45 to the previous upper limit, you would get the next upper limit. Okay, so I'm going to complete this out, and this is what the classes will look like. And you can see the very last data value appears 459, the max appears in that last, and will be counted in that last class. Now, so let's work on some of these until we get to a point where we can't, where it's going to be very hard to do the rest of the columns. So the upper limit. Now, we stopped this upper limit at 144, but it actually would include 144.9, 144.99, 144.999. Get the idea? It's the upper limit would be 145, but if we do hit 145, it's going to be counted in the next class. But even though 145 is not a data value that we would count in the first class, it is the upper limit of that class. And that is precisely the X value that we use in an ogive. All right, similarly, 189.99999, the upper limit. 234.9999 would be 235 as an upper limit. And you'll notice that the upper limits just match the lower limits of the next class. So I'm going to complete this one. And it would look, the rest of it would look like that. So you really have to calculate that upper limit because it is a number that you use. And one of the errors that students make, of course, is they use the upper limit to be 144 when it should be 145. All right, now the midpoint in this case, the next column, is fairly tricky as well because, what a lot of students will do is just say, oh, what number is right between 100 and 144? And in their head, they'll just go, 122. All right, well, it turns out that 122 is not the midpoint of the first class. It's close, but it's not quite. So come down here, and what we're looking for is the number right between each class. It's directly between. And to calculate that midpoint, it's like calculating the average of the two endpoints. In fact, the midpoint and the average formula are identical. So we're going to take 100 and add 145 and then divide by 2. And that puts us right in the middle. If you do this calculation, you'll see that it's not 122, it's 122.5. And so that's the midpoint that we will put here. Now, the only time we're going to be using the midpoint is if we're going to construct a frequency polygon. But again, what I'd like to do for you in this example is just put all these columns together, and this is all you need to do to create or complete in order to do any of the graphs that we've done up to this point. Well, just like the lower limits are jumping by 45, just like the upper limits are jumping by 45, the midpoints will also jump by 45. The tedious way to do this would be to, calculate the midpoint using the formula every single time. The easy way to do it is to get your calculator out and type in the first midpoint, 122.5, and then add 45 because the midpoints are jumping by 45 as well. And here they all are. So I'm going to enter those numbers into the midpoint column, and they would look like this. Just make sure as you're checking yourself that the midpoint does in fact fall in the class. So 392 is between 370 and 414, for example. Midpoint. Sometimes midpoints are very easy to calculate. If you want to know how many data values are in a class width, you subtract these numbers and add 1. And it's not as easy to see there, but if you had a class that was from 6 to 8, that would include the data values 6, 7, and 8. And if you'll notice, there are 3 different listed data values here. But if we just subtract 8 minus 6, we get 2. And we know that there are 3 there. So we always add 1 to get the number of data values. So if we take 144 and subtract 100, we get 44. But then if we add 1, we get 45, and that is the class width. All right, now we have to work on the Ys. And really all we need is the first column to be completed. This is where we need our help. Now, by brute force, you know how to do this, because all you have to do is to say, all right, I'm searching this list here for all of those data values between 100 and 144. And we just go through and we count them all. 100 is between 100 and 114 is. But just imagine the tedium of having to do this 8 different times for each class, going through and trying to count those data values. 60% of you would have an error, just by, of course, and if I'm included, and I would make errors. I'm terrible at it. So what we're going to do is we're going to rely on the technology. So what I want you to do, and the technology comes in very nicely for filling out that frequency column. And so let's take a look at how it works. So get your calculator out. Show me your calculator. Just show it up to your screen. I want to see what kind you guys are working with. Okay, the first thing we have to do is enter data. Some of these steps are going to be pretty easy for you because you've done it before. If not, I'm going to walk you through the steps. And the first thing you want to do is to enter the data. Now there are 40 sandwiches, so there are 40 data values here. And we're going to enter them in one at a time. So here are the steps to enter data. We're going to press the stat key. Let's see that. Okay, here's the stat key. We're always going to initiate our calculations with this key. Anytime you want, if you get a set of numerical data, then you're going to, a good first step would always be, even if it's 5 or 6 data values, always enter the numerical data into a list into your calculator. So stat, and you can see option number 1 is edit, and then it takes you to the lists. And even though these data values for these sandwiches appear in maybe 5 or 6 different lists, we're going to enter every single data value in a single list. Now I have stuff in here that I don't want, and so I'm going to clear it out. So maybe I'll add to this handout to clear a list. 1, highlight the list name, and then 2, hit clear, and then enter. So here's what it would look like if you did that. And here's the clear key. If you go here and just if you hit the delete key, you can delete out these data values one at a time. But what I'm suggesting is that you highlight the list name, in this case L1, so move with your arrow keys up to list 1, and then hit the clear key, and then the enter key down at the bottom right. And as soon as I hit enter, it wipes out everything in there. It's pretty quick. Clear enter, and you've got the list. All right, now we're going to enter in all of the data into list 1. And it's going to take me a second to do this, but you can do it as well. So I'm going to do it column by column, 5 columns, about 8 in each. So 100, 279, 147. After each data value, you hit enter. 263, 269. The time that it takes us to enter in all these data values will be much quicker in completing the column on frequency than if we went through the list 8 times and determined the frequencies that way. 273. Okay, so I'm not going to jump to list 2 and put these numbers in list 2. I'm just going to continue entering data into list 1. So I'll try to be a little faster with this. When you get to the bottom, if you highlight the last data value right here, you'll see that down in the input row, it tells you that you're in position 40. And that tells you that you've entered 40 data values. And that's good because you know you have 40 data values in this data set here. Now, in order to count up, which is what we're interested in here, the frequency, the count, in order to count them up, it would be nice if they were ordered. Because then if they were ordered from smallest to lowest, smallest to largest, we could just count them because they're going to be in order. We could count all the data values from 0 to 144 and then continue from there. All right, now to sort the data, which is the next thing we're going to do, you can see all of my data here are not sorted. There are two commands. There's the sort the data in ascending order, sort A, from smallest to largest. And then there's the other way that you can sort in descending order from largest to smallest. All right, I usually prefer just sorting data values in ascending order. All right, so to sort the data, we're going to go to the stat key again, here. And along with edit, where we enter in the data, right below that is where you're going to see the sort commands. So highlight number 2 and hit enter, or just press the number 2. And what you're going to see is sort ascending is going to go to your home screen. Now, you may have data in list 1, list 2, list 3, list 4, and so on. So you need to tell the calculator what list you want to sort. And we entered in all the data in L1, so we want to sort L1. Now, all of the list names are going to appear above a number key down here. So you can see in blue, L1, L2, L3, L4, L5, L6. L1, the variable L1 is right above the number 1. The variable L2 is right above the number 2, and so on for 1 through 6. Now, to get the blue L1, you need to hit the blue second key here. So I'm going to hit second, and then the number 1, and that gives me the variable L1. And then this tells me I want to sort L1. You can close off the parenthesis if you like, and then to execute the sort command, hit enter. Nothing interesting happens, but the calculator does say done. That is, I sorted your data for you. And then if you want to see where that data appears, go back to where your data are in list, and then edit. And now you'll notice that all of the data values in L1 have been sorted. Now what this will help you to do then, and let's get back to the frequency distribution, we are now going to count the data values between 100 and 144. 1, 2, 3, 4, 5, 6, 7. And the next one is above 144, so we don't want to count it. So it looks like there are 8 different data values in the first class. And you can continue like that and counting them up. But now they're all sorted for you, so it's much easier to count the data values. And but I want to show you one other thing. We're actually going to construct this histogram with the graphing calculator. The calculator can't do many constructions, but a histogram it can do. And so let me show you the steps for that. Here they are. And there are really 3 steps to it. The first one is that you want to set up a histogram, inform the calculator that you want to calculate or graph a histogram using the data in L1. Then you have to set the viewing window so that, the calculator doesn't automatically do it unless you ask it to automatically do it. And then after you set the viewing dimensions to see your histogram, that is, you identify the appropriate x-axis values and y-axis values. Then after you set up the window, then we're going to just hit the graph key and it'll draw your histogram for you. So let's go through these steps. Set up the histogram. Right above the y equals here is this command called stat plot. That means a statistical plot. It means a statistical graph. And so to get there, you have to hit the second key and then y equals. Second, y equals. And that's going to take you to the stat plots. You can see you have plot 1, plot 2, and plot 3. There are 3 different plots that you can construct at the same time. We only want one histogram. So we're just going to go inside the menu screen of plot 1 by hitting enter, and it takes us to this input screen. Inside plot 1, you want to turn it on. So with the cursor hovering over on, you want to physically hit enter, and that changes it from plot off to plot on. Then go down. You have 1, 2, 3, 4, 5, 6 different possible graphs that this graphing calculator will construct. And we want the one that looks like a histogram. So again, with the arrow keys, I'm going to move over until I'm hovering above the histogram. Now notice what's going to change when I hit enter here. The histogram only uses a single set of data, not an X and a Y. And so when I hit enter, it understands that, oh, you just have to give me one list. And so next to X list, you should see L1. If something else was there, like L6 or something like that, you just want to come back and hit second and then the number 1 to put L1 there. Now, for frequency, you can leave that as 1. What it means is that each data value we entered appears with frequency 1. We will have other lists in the future where we do have a frequency list, and we'll enter a list name under frequency, but not now. All right, so that's step 1, set up the histogram. It's now turned on, it's now set up as a histogram, and now we're going to set the viewing window. So let's go to window, right here. And when you go to the window, this is what you're going to see. Something like this. You may have different numbers typed in there, that's fine, but it allows you to change them all. Now, when we do our histogram, you might want to just draw it out. We're going to go from 100 up to 460. Like this. And then for the frequencies here, you know, we might go from, there might be classes with none in them. And if we have 40 data values, probably if we go up to 20, we'll capture, you know, the tallest bar. If you find that a histogram is flying off the top of your screen, then you'll want to go back and adjust the Y max. So here's the Y max, here's the Y min, here's the X max, and here's the X min, and here's the X max. Now, it's particularly important if you want our histogram that you set it up exactly in this way. You want the X min to be the min of the data set, and in this case, it's 100. You want the X max to be the upper limit of the last class, which is also the lower limit of the 9th class in this case, but we don't have a 9th class. So just go with the upper limit of the last class. And then the class width tells the calculator how wide you want the bars of the histogram. So just enter in your class width there, 45. All right, and then the Y values, you know, if we go from 0 to 20, that's probably good. But I always like to enter in -1, because if I enter in -1, then it's going to give me the entire line for the x-axis. And I like to see that. Let me enter in a smaller number here, like 5, and then just go on a scale of 1. So instead of 20 or 15, I'm just going to put 5. And that's it. That's this one. So the last thing you have to do to get your histogram is just hit the graph key. And there it is, graph. Just like you would graph an equation in algebra. All right, so this is not a very good one because you can see the first few bars, they fly off the top of the screen. So that means my Y max I didn't set high enough. So I'm going to go back to the window and change the Y max to, say, 15, and then graph again. And then you'll see that, so if you do the histogram like this, you'll be able to identify, you know, what is the shape of the distribution. But here's what's nice about this. Remember over here, some of you may have already done this and gone through and identified all of these. The beauty of the calculator is that if you hit the trace key right here, it traces on each bar. And in the process of tracing on each bar, it gives you the minimum value, the maximum value of the class, but more importantly, it gives you the frequency. So that frequency of the first class is 8. Then if you move your arrow keys, the right arrow in particular, you will go to the top of all the other bars. So the second bar that ranges from 145 to 190 has a frequency of 7. And then 9, 9, 3, 9, 9, 3, 1, 1, and 2. And you've got them all. And you can check to make sure that those frequencies add up to our 40 sandwiches. So it's really the frequency. This is where you want to use the graphing calculator for that column. And trust me, if you get good at typing in your data values, you'll be able to go through these problems much faster if you use your calculator, and you'll be more accurate than if you try to use just kind of scrolling through the data and counting up the data values yourself. All right, now these remaining columns, if you know what you're doing, they take about 10 seconds each, and they're all based on what you see currently. They're all based on the frequency. And so relative frequency, remember that these are like percentages. We take the frequency and divide by the total number, and then come up with a decimal. And I'll round each of these to 3 decimal places. 7 over 40, well, I don't know what that is exactly. 9 over 40, 9 over 40, and so on. So instead of writing the fraction versions, we write the decimal versions, because decimals are nicer to convert. They're easier to convert to, well, they just put you closer to converting percentages. And you should find when you add those, either the fractions or you add the decimals, the sum of all of those relative frequencies will add up to 1. In some cases where you have maybe a not so nice number of data values like 53, you're going to have to round those decimals to 3 decimal places, and you might have some rounding error, like you might end up with a sum of 1.001 or 0.999, something like that. All right, so these last 2 columns are the columns that we need for an ogive, and the first one we're going to do is just the frequency, but we're going to accumulate the frequencies as we go from the lower class limits to the upper class limits. So we're going to start, and we ask the question, as we're accumulating from, and we look at all data values in this class or all the classes that come before, well, there is no class for the first class, there is no class that comes before. So the cumulative frequency of the first class is equal to the frequency of the first class. Every other class after that, we're going to start accumulating. So for the next class, we have to add 7 and 8 to get 15. And the next one, we have to add 8, 7, and 9. And in the next class, we have to add 9, 9, 7, and 8. The easy way to do this is just to say, okay, I'm going to take the current running total, and I'm going to add the number in the next class. So 3 and 33 is equal to 36. And when you get done, you should have the number of data values at the bottom. The cumulative frequency of the last class is equal to the sample size. And that's what the rest of them look like. So it's just arithmetic, but you need to know how to do it. And then finally, just like we calculated the relative frequency by dividing everything by 40, we can divide the cumulative frequencies by 40 as well to get the relative cumulative frequency. The other way to think about this is just to add these relative frequencies as you go down the list. And then finally, in the very last one, you're going to get 40 over 40, so you're always going to get 1. So those are always going to match. You may have some rounding error if you have a tricky denominator like 53 or something like that. All right, again, I'll write these as decimals. So there's the table. And with this table, if you drew a table like this for any data set, you'll be able to construct by hand histograms, either with the relative frequency on the vertical axis or the frequency polygons, be able to construct those in or relative frequency polygons, or the cumulative frequencies on the vertical axis, I mean the ogive. One with cumulative frequency on the vertical axis and an ogive with the relative cumulative frequency on the ogive. All right, so just in review, the first column deals with the x, or the horizontal axis. The upper class limit is also the x. This is the x on the ogive. The midpoint is also an X. This is the X on the frequency polygon. Now all the frequencies are the Y's. So it really depends on the graph, but this is the Y coordinate, Y coordinate, Y coordinate, Y coordinate. The last two are used for ogives, one or the other. And these two are either used for frequency polygons or histograms. And again, you use just one of those. Okay, I'm going to skip the time series graph. I was going to have you practice one of those. And so if you want to do this, try a time series graph. And for this graph, if you want it to be misleading, then you could start the graph down here. Let's see. If you look at these numbers here, the lowest one is 744, and the highest one is looks like 89. So we could go up to 10 and maybe from 6 to 10. And over here on the time series, we would have 2003 and so on. And just plot all those points. And what you should see is dramatic growth. And a second graph that is not misleading, the x-axis will be the same, but start at 0 and go up to 10. And one of the graphs will be misleading, and the other one will be not misleading. And so it depends on whether you want the reader to be misled by your graph, or if you want them to infer their own reasoning on the graph. Some of the things that you can do to help you is to just maybe write down the coordinates of all the points. You know, the points that you select might be off from mine by a little bit because we have to interpret the Y value of these points. And we could come up with different estimates. But that's something that you can always do. In fact, those points that you have plotted there a lot of times will be the answers to some of the questions here. Okay, let's start with part width. What is the class width? Go ahead and enter it into the chat. Okay, good, 30. How many classes are represented? Okay, good, 7. Upper and lower limits of the second class. We would actually go from 15 to 45. And then the question was, how many classes? Now, if you draw a frequency distribution, you can actually draw one of those from this graph. You can see that the first class goes from -15 up to 14, but the upper class limit is 15. And the next one goes from 15 to 45, 45 to 75, and so on. It's actually these numbers that use the X value on the graph. These upper class limits are what we post. The only exception to that is the very first point, or the very first class, we plot both the lower class limit and the upper class limit. So here's your first class, and then here's your second, and then third and fourth and fifth and sixth and seventh. And those classes correspond to these 7 rows. So if you count the number of points and get 8, just know that the first point that's plotted there on the horizontal axis, that one doesn't actually represent a class in itself, because we use the upper class limits only. So we need, and the first class uses 2 points. So you don't want to doubly count that first class. So the number of points, 8 minus 1, 7, that's the number of classes. All right, so now you're going to be interpreting the number of children. And over here you have the frequencies. There should be cumulative frequencies, in fact. And this is the number of minutes that these elementary school students watch TV after school. And because of this point right here, we know that there's a total of 30 students in this sample. So how many of those 30? And when we're asking how many of the 30, we're looking at a frequency, and so we're going to focus on the Y coordinates, less than 105. So the way that you would interpret this is you go to 105, and you see the frequency that corresponds to that is 25. And so the benefit of ogives is that it gives us the number of data values at or less than a particular class. So we can read the number of students right off of this point. And the trickiest one is the last one, because it doesn't ask you about cumulative frequencies. 11 is correct. because it says the number of children that watch between 45 and 75. Now here's the cumulative frequency, so we know that there are 15 at that class or below, but if you wanted just the frequency, then what you would do is you would take these two categories and subtract them. And then here would be the corresponding frequencies. So if you had to work backwards, if you go from frequencies to cumulative frequencies, you take 2 plus 2 to get 4, plus 11 to get 15, plus 10 to get 25, and so on. If you go in the other direction and you have the cumulative frequencies, you have to subtract. So 4 minus 2 is 2. 15 minus 4 is 11. 25 minus 15 is 10, and so on. So the number in that class right there is indeed 11. So here they're asking for a y, here they're asking for a y, here they're asking for x. Class width is based on x, and so on.